This is a project on optical character recognition of numbers, and in it we have chosen the classifiers for classification. We have chosen we have basically chosen 4 feature extraction methods: hog, pixel intensity value, zoning, PCA, and we have matched based on research papers. We have matched the classifiers with them. Like hog is done for SVM and KN, and pixel intensity values is done for 2 classifiers. Zoning is done for random forest and logistic regression. PCA is done for SVM and logistic regression. And first of all, we have imported everything. And then we have split the data set into train and test with an 80 to 20 ratio. Basically, in the train folder, there are around 1000 plus images, and in the test folder there are basically 500 around images in each category. And then we have this is the code to access the folders, and then we come to hog feature extraction. Basically it goes from inside the folders and extracts the features of each and then saves it in this hog images, which basically come as hog. And the features are saved inside this NumPy array of the features test train labels are made, which are then used for classification, for training, and then testing. This is a scatter plot of the hog features of train, and this is for the test. And then in this part of the code, it's the classifier is first trained, and then it is tested on the test set. And then the classification report is generated with an accuracy of 0.96 of SVM with hog. And this is a visualization of some of the uh, images in the test set, like 0 was original value was 0, but it was predicted as 1. So this was a wrong prediction. But most of the predictions are correct for hog. The predictions may be wrong because of the feature extraction issue, or because when it was extracted, some of the features were not copied. And before everything else, the images are first, uh, there are like 4 steps applied on the images. They are resized, they are grayscaled, uh, so that they can, so that feature extraction may help those things. And then we have calculated for KNN 1, 2, and 3. For K values 1, 2, 3, and the accuracies plus the visualization of all of them are given for each value of K. And then we move on to pixel intensity values, in which we implemented KNN and CNN. The features of KNN are extracted and they are stored in this pixel folder, test and train labels of pixel intensity values using. And then again, इनका हमने scatter plot बनाया है, which shows the pixel intensity values of train and pixel intensity values of the test data. Then the model is trained. The model is first trained, and then the model is tested. For this again, KNN we have done for K true to 7. 1 was left out. one is actually calculated. But even for SVM and even for this, it was observed that it gave a 100% or a 99% accuracy because there was only one reference class, only one neighbor was considered. So in the grand scope, we didn't take it and we took from 2 to 7. And then the best class was considered. These 10 images are chosen at random from the test, and then we basically show that the true value is this and the predicted is this to show to help us visualize better. And then we have applied CNN, which is a deep learning model. So it was actually recommended in a research paper and it came with a 99% accuracy. Uh, the pixel intensity values are loaded and then they are applied. The model is first trained and then the predictions are made. It basically shows that the predictions are 99%. It shows a it shows a very good prediction. And even in the visualization, we can see that there are like no errors. The true and the predicted are same. And then we move on to PCA, which is basically we reduce the dimensionality of the features. So we first of all extract the PCA features and the extracted features are stored in this folder. First of all, only these were there, but these were generated afterwards because we did it for n component 10, 20, 30, 40, 50, 64, and the 95% variance n component was calculated using an algorithm, and we also found it for that. The previous values were found used through the research papers. A research paper used them, so we did use them as well. This is the graph that shows the variance, and it basically shows that a calculated one is 199, which contains 95% variance. And you note that after 199, it goes flat. So it's the point where you can get the highest features. And then for each component, we have calculated the accuracy. It's for each component, it shows the accuracy and then the visual uh, prediction. As you can see, for a few, it's wrong. This is PCA with 119 components and it shows an accuracy of 0.96. And after this, we actually tested for a few more, like a 200 and 300, and they were all showing the same result as 199. And then for logistic regression, PCA is applied and the accuracy of all the 10, 20, 30, 40, 50, 64, and 119 components was found along with visualization. And then lastly, we explored zoning. Zoning is basically a technique in which zones are made in the image. So for this, we first of all extracted the features which were stored here. Uh, The features were stored, but for both logistic regression and random forest, the test and train features were separately loaded as well. This scatter plot shows the train features of zoning. This scatter plot was basically made by first of all applying PCA and then it was made. The models are trained and their features are also found, extracted. And then the classification loop, random forest is also showing a 0.99. It is unsure still that if this accuracy is due to a glitch or due to some error or data leakage, or it's actually the accuracy. And with logistic regression, it's uh, not that good. It's 0.76% accuracy, meaning zoning with the logistic regression was just okay. There are a lot of wrong predictions. Like in this even two, it was 2 and it was predicted as 8. So this is basically all. Then in our report, we made a comparative analysis of all of these based on their accuracy uh, and different features, mainly accuracy. The report basically shows the comparison. The first of all discusses about all the processes we use, the mathematical equations behind them, and then it talks about the comparative report of all of them. And that's all. Thank you.